Let me show you the comparison of different transforms. Put time domain at one side, transform here, and frequency domain here. In time domain, if the signal is continuous and periodic, in time domain, we use Fourier series. By using Fourier series, we can get discrete and aperiodic signal. The signal must be a continuous signal and periodic signal in time domain. Then what kind of transform we can use? We can use Fourier series. Fourier series is the special types of transform where we can change the signal from time domain into frequency domain. We do this transformation from time domain into frequency domain. But what is the condition? The condition is that in time domain, the source signal must be a continuous signal and also a periodic signal. If the signal is not continuous or non-periodic, then Fourier series doesn't work. The source signal must be a continuous signal and periodic signal, then we can use Fourier series. Now when we change this signal from time domain into frequency domain, what we get? We get it in discrete form and in aperiodic form. Look, by using Fourier series in frequency domain, it is the other way around of the time domain. In time domain, the source signal was continuous signal and periodic, but after transformation, by using Fourier series, we get the signal in discrete form and also in non-periodic form in frequency domain. But what if the source signal is continuous and aperiodic, which means that non-periodic? We use Fourier Transform to get continuous and aperiodic signal in frequency domain. Now we have done for the Fourier series. For the Fourier series, the signal must be a continuous signal and periodic signal. But what's going to happen if the signal is continuous and non-periodic? Fourier series doesn't work. We use another type of transform, which is Fourier Transform. Now the quality of the Fourier Transform is that we can use it for the periodic signal and also for the aperiodic signal. Fourier Transform works for the periodic signal and aperiodic signal. After do transformation from time domain into frequency domain, we get a continuous signal and also aperiodic signal. Look, in the time domain, the source signal is continuous signal and aperiodic, which means that it is continuous and non-periodic. Look, we are using simple Fourier transform. We are not talking about discrete time, and fast Fourier transform. We are only talking about simple Fourier transform. By using simple Fourier transform, we're gonna get a continuous and non-periodic signal in frequency domain as well. The signal is continuous and aperiodic in time domain. We get the same form of the signal, which is continuous and aperiodic, which is in frequency domain. But what if the source signal is discrete and aperiodic in time domain? We're going to use discrete time Fourier transform to get discrete and non-periodic signal in frequency domain. Look, this time the signal is a digital signal. It is not analog signal. It is in discrete form and also non-periodic. So when the source signal is discrete and non-periodic in time domain, we're going to use discrete time Fourier transform. By using discrete time Fourier transform, the signal which is discrete and non-periodic in time domain will give the same form of discrete and non-periodic in frequency domain. But what if the signal is discrete but this time periodic in time domain? We're going to use discrete Fourier transform to get discrete and periodic signal in frequency domain. We just saw that if the source signal is discrete and non-periodic, we're going to use discrete time Fourier transform. But what if the signal is in discrete form and it is periodic in time domain? Then we're going to use discrete Fourier transform to get the same discrete and periodic form in frequency domain. Look, we do this transformation to transform the signal from time domain into frequency domain to do a much better analysis of the signal.